Okay, and we're going to take a couple notes. Those of you who already passed this back, everybody got to get a worksheet that I passed back? People in the front? Oh, I wrote it right yet. And who is Natalie's buddy? Taking notes. Okay. I'm videoing for her right now. Hey, Natalie. Okay. So, if mom sent you to the grocery store and she said, go grab a dozen bananas, what does that really mean to you? Go get 12. If mom sent you to the grocery store and said, go grab a mole of bananas, how many is that? 10 to the 23rd. Great. They probably don't have that in here, right?
Which means I'm not buying them.
Right. No, we're good.
So then I would just buy 6 bananas.
But that would be too easy. You just I just didn't listen. She wanted a mole of them, okay? So they don't have that many. So when we say mole, it is not itself some weird thing. Okay, it's not a thing either. It's a number. Like a dozen is 12. A mole is a number. What's that number?
6.022
10 to the 23rd, right? Some crazy big number like this. 6.022 times 10 to the 23rd. So a mole is not a thing. It is a huge number. So just remember that every time we say mole, think big number. And then after that, it's easy from there. But a mole can be equivalent to lots of things. Like a dozen is equivalent to 12. A baker's dozen is equivalent to 13. But if I said, what's the mass of those dozen bananas, you literally put 12 on there, mass them, and say, okay, it weighs, 3 pounds, whatever that is in grams. So a mole can also be equivalent to a number of grams of something or a certain volume of something. So these are all equivalencies. And if you look at this, does this remind you of Unit 1 a little bit?
Yeah.
With the whole canceling units, right? So I put the 3 big things we're talking about today up here. So we're going to have a certain number of moles, and we're going to multiply it by the ratio of 1 mole is equivalent to a certain number of liters, or 1 mole is equal to a certain number of particles, or guess what? 1 mole is equal to a certain mass. So 1 mole can be equivalent to lots of things. You just have to know exactly what we're being asked of, or what quantity we're talking about in terms of mass of water or number of particles of water. So it's all related back to the actual to the composition as well. So this is just to make sure we all know a mole means a number of something. Okay, so these are the 3 conversion factors we're working on. So I wrote them here. I'm going to write them here now. This is what you need to write down. These are the big 3. Put a big star by it because you are going to use them lots and lots and lots today. So Avogadro's, it's not avocado, it's Avogadro's constant is 1 mole is equal to 6.02, and for me it's 6.022 because that's the way I've learned it, and it's been drilled into my brain forever. 6.022 times 10 to the 23rd particles. Particles come in 3 varieties, though. Particles is just kind of a general umbrella term. So there are 3 different particles we could talk about. What is the word that you say to refer to an element? So something of an element. An atom of an element. Good. It's like an atom of iron. What's the word used to describe an ionic compound? Formula unit, right? So you can say, I have, a certain number of formula units of sodium chloride. And what term do you use to describe a covalently bound something? Molecule. So MOLE apostrophe C is not mole. It is my abbreviation for molecule, or you can just write out the full term molecule. So mole is not molecule. Mole is a huge number. Molecule is like a molecule of carbon dioxide is a thing. So we're going to kind of put some images with these 2. But that's what that conversion factor between moles and numbers of particles. Then you have this thing called molar mass. What 2 quantities, what 2 units do you think are involved here? Say again? Molar mass. Moles and mass, right? So 1 mole is equal to some number of grams of that substance. So we've already actually done molar mass. I just didn't tell you that's what it was called. In our last unit, when we were adding up the masses of individual atoms in, let's say, carbon tetrafluoride or carbon tetrachloride or something like that, you already know how to do molar mass. It's just adding. So let's just do a quick example here. What's the molar mass of carbon tetrachloride? tell me, you guys have your periodic table out, right? You have the BFF with you today? You need it. So get your periodic table out and tell me, how do you get the molar mass of carbon tetrachloride?
The formula units and the molecules, what it means?
Well,
This one is referring to an ionic substance. So we say formula unit, and if it's for a molecule, we're talking about covalent. So I'm glad you asked someone to actually write that there. And that's referring to an element.
Thank you.
So carbon weighs what? 12.01 grams. Don't cut it short. It's that little bit does count. And then how many chlorines are here? 4. So plus 4 times chlorine's mass, 35.45 grams. So 71, 41, 41, 153 point something. What is it? 153.8. And this is how you write the units, okay? So if we just said one carbon tetrachloride added together is this many grams, it's not just that many grams, it's that many grams per mole of itself. So it's this per 1 mole. That is the molar mass, that fraction, that conversion factor, whatever you want to call it. It's the molar mass. It's 2 units represented inside. Because if it was just mass, I would have just said, what's the mass of that? But if I said the molar mass, you're including both moles and mass. Do not get that wrong on the quest. We have a quest on this first part of the unit. What's our quest? A quest is a quiz test. Okay? We're on a quest. Quiz test quest? Yeah? Got me? It's just a little test. It's like a big quiz. A little test. Okay?
Kind of like when you eat a big lunch, so you have a small dinner.
Yeah. But we're actually going to have a small lunch. We'll have like a small lunch, and then we'll have a big dinner later on in this unit. This unit's long, so I'm doing a small lunch first, and then we'll have a big dinner later. Good analogy. Okay, so we got molar mass taken care of. Molar volume, what 2 units are involved here? Moles and, what's the unit for volume? Liters, right? So molar volume is including moles and liters, and this is very specific. This is at STP. So 1 mole is of a gas at STP. This is just some extra information we need to know. At STP is equivalent to 22.4 liters of that gas. And that's one of the things you write down in your reading guide. So that's only specifically at STP. So we're actually writing a lot of notes on this one, so I won't do as much later. So at STP means what again? Standard temperature. What's that temperature? Say it again. 0 degrees Celsius. Close. 0 degrees Celsius, which is 273 Kelvin. Yeah? And then standard pressure is the what number? 101.3. 101.3 kilopascals, kPa, kilopascals. That's 1 atmosphere, though. That equals 1 atmosphere, 1 ATM. So 0 degrees Celsius equals 273 Kelvin. Those are interchangeable. Same thing here. 101.3 kilopascals is equal to 1 atmosphere. And we're going to use these a lot in our next unit, gases, and gases unit's really fun. So we'll see those units over and over again. Okay, so 3 conversion factors today. That's it. But we need to remember how to convert. We need to remember how to cancel units. We need to remember that 1 mole is equivalent to these 3 things. So that's what we're going to practice a bit more today. Okie dokie, artichokes. Moving on. Okay, so this is on your paper, I believe. Close to it anyway. Maybe it's the one below. And we just went over some of this, so I'm actually going to, I'll tell you what new stuff to write down, but there won't be a whole lot here. So we know that when we talk about chemistry, we talk about science, we all record things in the SI system. So that's what we're learning about the mole today, because it's a part of the SI system, the International System of Measurement. So it's a unit for amount of a substance, and that's what we just said. A mole is equal to a big number, an amount, a counting number. And so we already talked about that. 1 mole is that many particles. So the definition of a mole will allow us to convert between what 2 units? If we're just talking about that part of it. It allows us to convert between moles and, I heard it, particles, good. So that's just kind of like okay, she's got the 2 units there, we're converting between those 2 units. And then those particles we just talked about are here. If you want an example of them, the examples are listed kind of right behind it. So an atom is referring to an element, for example, iron, something straight from the PTOE. So remember, elements are just straight from the periodic table of elements. And then we have particles, so we have 2 more particles, molecules, and formula units. And so 2 examples would be sodium chloride will be a good example of a covalent compound. Good example of covalent compound. I'm not breathing that out, right? Carbon dioxide. Okay. Oh, the diatomic molecules are, this is my note to myself. Diatomic. What do those 2 things mean together? 2 atoms. What are the 7 diatomic molecules that you should know? We wrote them down, but I want to make sure we know them. So before you tell me, the 7 make a big 7 on the periodic table. I call it the big 7 plus hydrogen. So what does the big 7 consist of? Hydrogen, which is over here on the periodic table, and then these elements here. Nitrogen, oxygen. What's next to oxygen? Fluorine, yeah. Fluorine. I lied to you? Yeah, oxygen, fluorine, okay. Down. Chlorine. Bromine and iodine. Okay, big 7 and hydrogen, yeah? The big 7. That's a 7. Yeah? You see it?
Yeah.
And guess how many there are? 1, 2, 3, 4, 5, 6, 7. 7. Astatine, the 18 down there, is not really, it's a diatomic, but we never, ever see it, like 0%. So there we go. The big 7 is this, and then hydrogen, because it's weird, it's got to be over there by itself. No, I forgot to collect. We knew that one. Sorry.
That's a random question.
It's for the coin drop. It wasn't random. Okay. Do you have any money?
Yeah. Just came in like,
Okay, so we got our diatomics. So even though these are 2 atoms, we still say that's a molecule. So this is a molecule of hydrogen gas. This is a molecule of nitrogen gas. This is a molecule of oxygen gas. This is a molecule of chlorine gas. This is a molecule of fluorine, and a molecule of bromine, and a molecule of iodine. So diatomic, how do they look? They have 2's after them, subscript-wise. Okay? Sorry, I'm not sidetracked. I'm just really excited just to make sure we know what our diatomics are. And going, is that good? Okay. One more second. Just the big 7 with just 2's on them. Diatomic, 2. That's it. Okay, how do these babies look? If I see, ooh, what's the name that? 02072 minus. Dichromate, you're awesome. So dichromate looks like this, but that is a humongous polyatomic ion, right? So that is a, when it's together, it's actually, you can see NH4, which is what? So ammonium dichromate. That's a formula unit of ammonium dichromate. That's a formula unit of Cr2O3. It's not an ion. It's a formula unit, so it's an ionic compound. So 2 names. Chromium. Chromium is a transition metal. Chromium 3 oxide. Okay, so we've got ammonium dichromate, 1 formula unit of that. Chromium 3 oxide, which we have 1 formula unit of that. We have a what of nitrogen? Diatomic molecule, because it's still covalent. And then we have 4 water molecules. So that vocabulary does mean stuff, okay? Don't just like, hey, I have a thing of that and a thing of that. I got 4 things of that. Those things have names. Formula unit, molecule. Okay, so that's kind of what that just was about. And then this right here is what I want to do, okay? So I'm scooching down here. This is a lot of information, but I think this information will make sense when I do an example. So now we've transitioned from particles to molar mass. So now this is just a little bit more information on molar mass. So the definition of molar mass is the mass of 1 mole of any compound or element, because it can be as just a singleton by itself too, is equal to the atomic mass on the periodic table, which is the sum in a compound. So that's basically what we just did with our example of carbon tetrachloride, I think we just did. We said it weighed 153.8 grams per mole because we added it up. So that's all this is grams per mole. So the mass of 1 mole of sulfur is, don't look at me,
32.07.
32.07 what? Grams, okay? So this one says the mass, so the mass is recorded in grams of 1 mole, okay? The atoms, how many atoms, is our question, are in 55.8 grams of iron? So maybe tell me what the significance of 55.8 grams is. That's the what? The molar mass? Yeah? But the molar, so on the PTOE, you see that number, right? On the PTOE, so that's saying 1 mole of iron weighs 55.8 grams. Okay? So 1 mole of iron weighs that much. But I'm asking you how many atoms are in that amount. Huh? So if 1 mole, if this is equal to 1 mole, that's the mass of 1 mole. How many particles are in 1 mole? 6, so Avogadro's number is 6.022 times 10 to the 23rd particles. So sometimes I'm not going to say, oh, well, I'm going to give you 1 mole. How many particles are in 1 mole? You know in 1 mole there's 6.022 times 10 to the 23rd particles. But I might start you off and say, oh, here's this random mass. And you're like, oh, she wants me to backtrack, go from mass to moles, and then use my knowledge of that to get to particles. This is the 2-thought process. But just because that's the molar mass on the periodic table, you understand that's 1 mole. And then from 1 mole, you say that's how many particles, 6.022 times 10 to the 23rd. Okay, so let's try again. If I wanted 6.022 times 10 to the 23rd atoms of carbon, what mass of carbon do I need? You shouldn't be looking at me. How do you know? Right, so on the PTOE, you look there, and it says carbon weighs 12.01 grams per mole. Even though it doesn't say grams per mole in the periodic table, you're assuming if you're looking at one of them, that means 1 mole. So if I asked you for how many atoms, and you're like, oh, hey, that's 1 mole of atoms. 1 mole of atoms weighs whatever the mass of the periodic table says. So just connecting mass and moles and particles now. So we got one more thing to talk about. Let's just practice one or two more of these, and then I'll move on to that actually. So this is just an equivalency. It's just a conversion factor. We're going from moles to grams or moles to particles or both. So let's add up the molar mass of ethene. This is ethene gas. What's the molar mass of that? Tell me your thought process. Question first. Yeah.
So how many atoms are inside 55.8 grams of iron?
How many atoms? Oh, I'm sorry. 1 mole of them. 1 mole of atoms is Avogadro's number. 6.022 times 10 to the 23rd particles or atoms. It's because 1 mole is equal to Avogadro's number. 1 mole is equal to Avogadro's number. So that's why, since 55.85 grams is what's on the periodic table, that is equivalent to 1 mole of iron. That 1 mole of iron is Avogadro's number. They're all equivalent. It's like saying a dozen is 12. Mole is 6.022 times 10 to the 23rd. Okay, down here, adding up 2 carbons and 6 hydrogens, go. 2 times what? Okay, plus what? 6 times 1.008. 30 point what? 068 grams per mole, 1 mole of Fe. So I'm just writing that for you because I want you to recognize that molar mass always has 2 units, grams per mole. Okay, so this is all background information still. We haven't even really started converting things yet, but we will. We will. And 30.068 grams per mole. Okay. So, that's not important right now. Last thing, this is the last bit of information. We've already talked about this. We talked about 1 mole of gas, 22.4 liters per mole, 22.4 liters at STP per mole, standard temperature and pressure. We already talked about all this. Anything new here? Not really? So I'm going to give you a scenario. We have 2 moles of carbon dioxide gas. Okay, so it's my given. 2 moles of CO2 gas. Question. How many liters at STP does that gas take up? Yeah. So what did you just do in your head?
So it's like 22 22.4 per mole, so if there's 2 moles, and there's 2, but
So there's two.
you know what
It's doubled, right? But you actually did stoichiometry in your head. You did dimensional analysis in your head. But I like to see it. I like to see that dimensional analysis. So what did he just do? He set up in his head 1 mole of CO2 has what volume? 22.4 liters. This should resonate with you. You've seen this many times. You've seen dimensional analysis, stoichiometry, chemistry math, right? Whatever you want to call it. But why are we setting it this way and not flipped? Why are we putting a conversion factor like this? So the moles cancel. So 2 moles, the mole unit cancels with this mole unit, leaving us with units of liters. Yeah? So you could do that in your head, 2 times 22.4. But I want you to realize you actually are doing stoichiometry. You are. So let's do another one. But let's go back to do moles and particles or another example. So I'm going to leave this one here for a second. Let you guys copy down to YouTube. And then the examples to follow. I'll give you just one more system here. I have my clicker. Because I have lots of examples, but you have to tell me where we stop because you may not need as many as you want to do. Oh, and I'm on your paper now. Yeah, class examples, you see on your paper? That's what we're doing. There's probably no way you're going to write your work on that paper, okay? Because it's really just too small. So on the back maybe, but not right next to it. So just label it class examples, put on the back. Or in separate sheet of paper, don't care. But here we go. This is a method. The method of solving these we've already talked about, like where you start with a given quantity and you put a question mark for your unknown. I'm going to force you to do that at first because you're going to thank yourself because you won't, when we start reading word problems, you'll thank yourself because you have a method on how to solve the word problems. These are simple because it's not even a full sentence. You can't get lost. You can't get lost in units, but with word problems sometimes you can. So our question is, we want to know how many moles 2.0 or 80 times 10 to the 24th atoms of silicon is. So our given is which of these? Yeah, the number of atoms, right? So I'm going to write out my given. So you always want to start with your given. Start with your given and then convert to your unknown. Okay? So we're starting with 2.80 times 10 to the 24th atoms of silicon. You have to write down what you're referring to. Sometimes we're going to change identities, like we might change from down here sulfur trioxide to just oxygen. So it's very important to write down as I there, okay? So this is one big number, I understand. But we want to convert to what unit? Moles, right? So that unit must go where? On the fraction. On the top. So remember, it's always 1 mole. So 1 always goes with a mole in your conversion process. So 1 mole is equal to how many atoms? Shout it out. Yep, 6.022 times 10 to the 23rd atoms. So this is an equivalency. So this is the same over the same. I know it looks different, but they're literally the same thing. So what am I really multiplying by? If it's same over same. 1. I'm not changing that number of atoms at all. I'm just representing it in a different way. Like 1 dozen is 12 bananas. They're the same thing, but I'm just saying it in a different way. Yeah.
Why does the one on the left say 24 and the one on the bottom?
Because this was my given, so I wrote down exactly what is told. This is a standard unit or number you must memorize, 10 to the 23rd. So it's a totally different number because this is a standard, and this can change. The given can change a million times. The given is going to be given to you in the problem. Yeah.
still divide.
Yes, you still divide. Because I want to represent it in moles now and not atoms. But atoms and atoms do cancel. In your calculator, you must put parentheses or your calculator will not know where to apply that whole times 10 to the 24th or times 10 to the 23rd. So I'm putting parentheses here to remind you of that. Go ahead and try it. Phone calculator, normal calculator, go ahead and try it. Yeah. I have more, but this is my personal one, so just make sure. Use that. Mr. McNeil has all of those. So tell me what you get, people. I have my answers too. Anybody up? Go for it. Yeah, question?
So are we doing that divided by the gallon?
Yep. So this big number, parentheses, divided by this number in parentheses. Yeah. 4.649 moles. Is that what you got at first, though? Okay. So that's how many moles of silicon that is, and that should make sense. If you look, it's like we have a difference of 10 here. So the 10 to the 24th versus the 10 to the 23rd means you're going to get a number greater than 1, and then it's like 28 divided by 6, which is about 4, a little bit more than 4. So that actually mathematically, mental math makes sense. That needs to be rounded to how many sig figs? How many sig figs are in this problem? 3. How many in this one? 4. So we're going to go to 3 sig figs. That goes to what? 4.65 moles of silicon. All right. I'm forcing you to practice in your calculator because I don't want you to mistakenly think that you're doing it right and you're not doing it right in your calculator. You're probably doing it right on paper, but not in your calculator. Okay. So next one. 0.32 moles of potassium to grams. What is our question? Grams, right? So don't forget, we're going to grams of potassium. Potassium is K, not P. All right, so what am I starting with? 0.32 moles of K. I need to convert and put what on top? Okay, what unit on top there? Right, so you want to put grams on top. And what unit do you want on bottom? Moles, because you want to cancel out moles, right? Then before you really move on, you have to make sure, is that possible? Like, is there a conversion between moles of K and grams of K? Yeah or no? Yes. Yes. 1 mole is equivalent to a certain number of grams of potassium. There are 3 conversions with moles. Moles can be converted directly to liters of gas, moles can be converted directly to particles, or moles can be converted directly to grams. Those are direct conversions, or one-steppers. What's the number for grams of potassium? Where should you be looking? You're looking on the PTOE, right? It's an element. You can find it directly on the PTOE. 39.10 grams of potassium is what the periodic table says. That's easy. 0.32 multiplied by 39.1. What do you get? Anybody? Thanks, Jalen. I think that's a decimal. I don't know. Multiply that again.
Oh, shoot.
Yeah. 12.512 grams of potassium. Okay, so don't forget, 1 mole is equivalent to a number on the periodic table if it's just simply an element. And the moles could cancel, so then you multiply it. So then we have to take this to sig figs. How many sig figs should be recorded? 2, so round me. The 5 does round that 2 up, right? So don't forget, you look at the 12, but you're like, let me look at the next number just to make sure. Nope, it does round it up to 13 grams of potassium. Okay? Potassium. Next, now we have a problem. We actually have sulfur trioxide that we're starting with, but we're going to atoms of oxygen. So that's not a direct conversion. That's a 2 or 3 step process. So we need to remember just to write down to the side atoms of O, and that's not diatomic oxygen. That's just simply the atom oxygen, just O. And then tell me what we're starting with. What do we have to start with? 1.14 moles of sulfur trioxide. Okay? I am in moles, which is great. And moles can get me anywhere. Moles can get me to gas, liters, it can get me to particles, or it can get me to grams. Which of these is probably the important one? Could get me to particles, because that could get me then to particles of oxygen. But there's something that I've not told you. It's called an internal mole ratio. And that internal mole ratio is something you're going to use right now before we even have to get to particles. Because I know you saw atoms, you're like, oh, atoms are one of the 3 particles, I have to use Avogadro's number, but not yet. So 1 mole of sulfur trioxide is going to go on bottom. And I want you to dissect sulfur trioxide. when you dissect it and you think about what it looks like visually, I'm just going to draw a quick sketch. It's not exactly what it looks like. But that's the kind of the Lewis dot structure with all the dots. How many oxygens are in, so how many moles of oxygen are in 1 mole of sulfur trioxide? 3. It's a ratio. For one of these guys, there are 1, 2, 3 oxygens. So it's called an internal ratio because you're really dissecting the molecule as a whole. So there's 3 moles, or 3 times as many oxygens in 1 sulfur trioxide than a sulfur trioxide. Does that kind of make sense? You're actually just looking at the subscript. That's all you're doing. You're saying there's 3 of them in 1 of those. So we have an internal mole ratio. That's what we just did. Now we can cancel moles of sulfur trioxide. Okay, now I'm to moles of oxygen. Can I go from moles of oxygen to atoms of oxygen? With what conversion? There's only 3 to choose from, right? Which one? Avogadro's number, right? So now I'm taking just 1 mole, not the 3 moles of oxygen. That 3 is just stay in there because that was an internal ratio. You write down 1 mole of oxygen here, and then you tell me how many atoms of oxygen are in a mole. 6.022 times 10 to the 23rd atoms. Anytime you're going from moles to atoms or moles to particles in general, you have to use Avogadro's number. So that's moles of oxygen. Okay? And then we already canceled our moles of sulfur trioxide. Then you just verify you have moles of oxygen canceling. Notice I'm not canceling the 3. The 3 is required for calculation purposes. And then you're going to multiply by the 6.022 times 10 to the 23rd. I'll give you a second there. Go for it. Okay, so what did you guys get? You did 1.14 times 3 times 6.022 times 10 to the 23rd. Good. Atoms of oxygen. All right, so sig figs. Don't so I will tell you, no sig figs on ratios, because the ratios are not a measurement. Sig figs are all about measurement. So we have a measurement of 1.14 moles of sulfur trioxide. We have a measurement of this many atoms in a mole. But a ratio is not really a measurement, so do not record this to 1 sig fig. Record this to how many sig figs? 3, because this one over here has 3 sig figs, and this one has 4, so you go with the 3, because that's the limiting one. So this would be 2.06, still though, times 10 to the 23rd atoms, because there's a ton of atoms in this, of oxygen. So here's our final answer. 2.06 times 10 to the 23rd. Whew. So you're going to see a theme. Anytime you have a mole, you can convert it to this, 4 grams. But you've got to just be aware of what you're going to. All right, let's finish these. We have so many moles of sodium phosphate, 2 grams. Notice that, yeah. Oh, did you say 24th? Why 10 to the 24th? Is that what your calculator says? 3 times 1. I don't know why I recorded 23rd. I'm guessing you guys are good. I just recorded to 23rd for some reason. That makes sense though. 24th. Thank you. Okay, so this one, I'm giving you sodium phosphate. I'm not going to write down names anymore because you are masters of chemistry. So tell me what I'm starting with here. So I'm starting with the number 4.52 times 10 to the negative 3 moles of what? Tell me the formula. Go for it. Na3, PO4. Okay. So sodium phosphate. Good try, thank you. But you guys are going to keep working on these. So if I have that, and I want to get to grams of sodium phosphate, how many steps do I take to get there? What do you guys think? I'm in moles. Remember, moles can get me directly to what, or what. It can get me directly to grams. I just heard it, right? So why take more than one step? This is a one-step process. If I have moles, then I can go directly to grams by getting the molar mass of sodium phosphate. So get that calculator out. Let's add it up. Sodium. I'm just going to write it down here for you. You can just, this is something you can put directly in your calculator. You do not have to show me how to calculate molar mass. It's adding. Don't show me that. But for you, 3 times what for sodium? 22.99 grams for sodium, plus what for phosphorus? 30.97 for phosphorus, plus 4 oxygens. And so this is a good point I'm going to make right now. I think you guys know it, but just in case, that 4 only applies to O, because behind the P is an imaginary what? 1. Okay, so don't forget that. But if there were parentheses or something, that parentheses means the subscript applies to the whole shebang inside the parentheses. We'll do an example of that later. All right, so 4 times what for oxygen? 16 grams. So tell me the molar mass of that. 163.97? 163.94. Different periodic tables have different values published, so mine might be slightly different from yours, specifically like on the answer key for a problem set, so just beware. So if you're close to me, we're good. It just matters what periodic table you're using. Okay, so this mass is the molar mass of of sodium phosphate. Where does that number go on this fraction? On top. 163.94 grams per what? 1 mole. Per 1 mole of sodium phosphate. Okay, and I'm at grams, right? So let's calculate. How do you calculate this one, by the way? Tell me exactly what you put in your calculator. That, Jalen, put this in your calculator. 4.5, so parentheses, 4.52 times 10 to the negative 3, and parentheses, then what? Do times it. Times it by 163.94. I was thinking for some reason we are dividing. So tell me what you guys get. Because it was phosphate, so PO4 3 minus, sodium 1 plus, ionic, so we crisscrossed it. That 3 went down here, that 1 went down here. From phosphate's charge, it's memorized. If you don't have it memorized yet, you still got time. Nomenclature quizzes are happening every day until we all get 90s. I'm ready. Are you ready?
0.0741
grams of sodium phosphate. There we go. 3 sig figs all the way. I think we need 2 more examples. How about you?
0.02.
Point what? Is this right? Thank you. Okay, I'm just making sure I don't have any more typos on my key. Yeah. If you can't go, but if you can wait, just wait. Okay. Liters of carbon dioxide to atoms of oxygen. Again, what do you notice, guys? Look up here. Carbon dioxide to oxygen. What do you think I'm going to have to use? What is internal mole ratio? Okay, we're going to have to use that internal mole ratio. But what am I starting with? 2.5 times 10 to the second L liters of what's carbon dioxide? CO2. I don't think anybody has a question on that. All right. I'm in liters. There's only one place I can go from liters. What unit? Mole. I can't go to grams. I can't go to particles. I have to use the mole. The mole is a stepping stone to get you to other places, okay? So for liters back to moles, what do I do for my fraction here? Put mole on top. So 1 mole of CO2 on top. What goes on bottom? That number. No. 22.4 liters. Because remember, you're canceling liters. So the number that goes with liters is 22.4. The number that goes with particles is Avogadro's number. So we have to cancel liters of CO2. So liters of CO2 cancel on the bottom because they are top and bottom. Anything that's top and bottom will cancel. And then I need to get from moles of carbon dioxide to something different. What is that something different I'm getting to? moles of oxygen. How do I do that internal mole ratio thing again? 2 to 1. How do you know 2 to 1? Because there's 2 oxygens inside of 1 carbon dioxide, right? So there's 2 moles of oxygen inside of 1 mole of CO2, carbon dioxide. So you're just looking at the subscript, and so there's a 2 there, so you put 2 moles of oxygen there. And this actually, I'm telling you this now because it actually saves you a lot of steps. Sometimes these will be like 5 steps if you don't do that. Ain't nobody got time for that, okay? So 1 mole of CO2, 1 mole of CO2, or sorry, the moles of CO2 cancel. We're in 2 moles of oxygen. We're still not to atoms of oxygen. How do we get from moles of something to atoms of something? Anybody? I hear you. Avogadro's number. So I'm putting 1 mole of O. Again, it doesn't matter about the number here. I'm just looking at the unit. Units have to cancel. So 1 mole of oxygen is 6.022 times 10 to the 23rd atoms of oxygen. Calculate that, baby. Yeah.
Why do you have the two moles of oxygen?
It's called that's the internal ratio argument again. So this step right here is internal mole ratio, because in 1 mole of CO2, which looks like that, this is actually 1 molecule of CO2. 1 molecule of CO2 contains 2 atoms of oxygen. It truly does. But if I have to go from moles to molecules and then back to moles to get to atoms, I'm going through moles twice, basically, is what I'm saying. So moles end up being on top and on bottom. Avogadro's number ends up being on top and on bottom. So I know I'm going to cancel out Avogadro's number because it's up there twice. And it's just simply, like, that's what I said, this could be a 5-step process. So I'm telling you the trick, and this trick is called the internal mole ratio. So if you think of me having a full mole of these guys, I'm going to have double the amount of oxygen internally. So that's why double is 2 over 1. And so the subscript there indicates to me the internal mole ratio. And it's actually just a quicker process. I'm actually telling you a trick right now. And I hope it helps, but it is sometimes confusing because it's the first time you've ever seen this. Okay, answer. Answer? Let's focus with me. 1.34 times 10 to the 25th atoms of oxygen. Don't forget that it's 10 to the second over here, divided by 22.4 times 2 times 6.022 times 10 to the 23rd. Yeah.
Your final answer, would you have to make it
Sig to sig figs, yeah, so 1.3. Good point, 1.3. That was my next step. Okay, last one for me for now. So I'm trying to model exact, like, one of every single example. This is the last one. We have formula units of lead 2 iodide going to grams of lead 2 iodide. So if it's the same thing, it's actually a little simpler. So what am I starting off with? I hear you, 1.9 times 10 to the 21st. Formula units of lead 2 iodide. What is that? Formula. Go for it. No.
I mean PV.
PV. PV. I2. Good. Because lead 2, iodine's a 1, crisscross. It starts with a metal, it's ionic, so you have to get the ionic charges and crisscross. Okay? I'm in formula units. I can't go anywhere but where? Moles. Give me the moles. What goes on top? 1 mole goes on top, because I got to get 2 moles. Moles has to go on top of lead 2 iodide. And then what goes on bottom? I'm getting, so don't forget, formula units is a special word for particle. 6.022 times 10 to the 23rd formula units of lead 2 iodide. So don't forget, formula units is a special particle. Particle means Avogadro's number. So formula units and formula units cancel. Now I'm in moles of lead 2 iodide. Moles is my special unit that gets me anywhere. But where do I want to go? Grams. And how do I get to grams? Look on the periodic table. So tell me the lead 2 iodide's molar mass. You might have to add it up. So like, I think lead's 2.8 I mean, 207.9.2
It's still 7.
grams plus 122 times 126.9. What's lead to iodide? So that was lead plus 2 iodines. Say again? 461.2 grams. Oh, even. Sorry, I apparently had a different periodic table, but there we go. That's your grams by adding lead plus iodine plus iodine. That number goes up here on top. So 461 grams of lead to iodide is equal to 1 mole of itself. And so moles of lead to iodide cancel. Only unit left is grams of lead to iodide, which is what I wanted. So in your calculator, what are you doing? Number. Yeah. Cool. What else? Divide by parentheses 6.022 times 10 to the 23rd. And then times, because anything on top you're multiplying by, anything on bottom you're dividing by, 461. Grams of lead to iodine. Woo! So, back to the basics, right? We are canceling units. We are looking at dimensional analysis. The new thing today are the 3 relationships. Moles to liters, moles to particles, moles to grams. You cannot go straight from grams to moles or straight from grams to particles. These don't have relationships together. Everybody's related back to the mole, so you will be hitting the mole a lot. These are yours. I'm going to let you guys start right now, and then if we can get a break, we'll get a break in, and we'll go outside and do something real fast and come back. Okay? Impress me. Get the first 2 done. Get her done. Quickly. Do you see them on your paper? Yeah. There's 8 of them. Right? So student practice. I'm just making sure you actually see these are on your paper. What you don't finish for me now, you will finish tonight. Okay? So the more you get done now, the better. It's called student practice from here. Do the first 2 for sure right now. I want to see what you guys get. Talk to your neighbor if you need to, or me. So we just took some notes on video and you can watch the front page. Guys, I'm looking and I'm judging you on your formula people, on your equations. I'm judging you. You have access to me.
Oh, why is it so long? Oh, I couldn't get it.
Lizzie, focus. Oh, yeah, that's right. You were late. What is chromium 3 oxide? Where is that 2 coming from? The oxygen's charge, and then the 3 is coming from the chromium's charge. That is going to be second nature to you very soon. What'd you do next? What'd you do next? You added the mass up. What was the mass? I heard 152. Okay, I didn't know if there was any dots. Okay, and then what is that per? Per what? Per 1 mole. Why did you use the molar mass in this one? You're going from moles to mass of that same stuff, so it's a one-stepper. Multiply, so moles and moles canceled. What'd you guys get? You can do that in your head. 520 grams of chromium 3 oxide. Cool, keep going. And go ahead and go through number 3. If you're already done, you know you gotta do all of them, so keep going. Wait, don't stop. Who's gonna be gone from my class tomorrow? You in the first half of the alphabet. Okay, just wondering.
Yeah, registration.
Okay, focus. I'm sorry, I did not mean to distract you. I did not mean to distract you. Yeah. Only oh no, that looks good. Let me write the answer on the board.
No! Oh wait, it may not be right.
Wow,
No, that's right. That's right.
It is?
Okay, let me get your attention back. 5, 4, 3, 2, 1. Sorry to even mention that whole PSAT thing, but I just need to make sure. So I'm actually going to make sure, since I'm missing half of you guys tomorrow, make sure that you get all of these. And those of you who are here tomorrow, we'll do the activity. And then those of you who are not here tomorrow, you will make up the activity. The activity is very quick, like 20 minutes, like teal time, no problem. Okay? But I want you to make sure you finish these and get these done today. That means you have limited homework. It means tonight you will just finish problem set, not finish problem set 10, begin problem set 10, just stuff we talked about today. And then if you need to talk about your Mythbusters buddy, have you guys decided on Mythbusters buddies? Okay, I'll explain that a little bit more in about 10 minutes. I'll explain it in about 10 minutes. Keep working on this right now. periodic table. Yeah. Canceling particles. But that's not moles, Okay, quick recap. Particles come in three varieties. Particles is an umbrella term. But what does it really describe? What are the three different units I could describe as a particle? Atoms, molecules, or formula units, right? So almost never will you actually write the word particles, right? These particles will either be molecules, formula units, or atoms. But if you are writing that in a conversion factor, that number will always be Avogadro's number. So never will you ever go from grams straight to particles. Grams will get you to what unit? Moles. Moles is a stepping stone. And then you're going to go from moles to particles using something like this. Okay? It's not going to say particles. It's going to say molecules, formula units, or atoms. Yeah, question? And I'll do number 3 on the board, but you guys got to challenge yourself to bring together what we just talked about. Yeah. Okay, I'm not going to come and hover. I will write them on the board to keep going without me. I'm just giving people chances to do it without looking on the board. I don't like to hold your guys' hands. It's just weird. What? You guys can hold each other's hands if it helps, but we all knew that was carbon tetrachloride, though. I know we did. So the unit on top leads you to tell you what to cancel, right? It's not a question. It's not a game. It's like, this has to be canceled. So you have to put 1 mole of carbon tetrachloride on the bottom. And I think we already added that up. It was 153.8, according to my lovely people who calculate for me. They make it calculate. Yeah, approximately. Moles of carbon tetrachloride, moles of carbon tetrachloride, whatever that is. Mine might be a teeny bit off from yours because I calculated it slightly different. No, exactly same old math. Never mind. It should be 1.2 times 10 to the negative 46. Anybody? Yeah. Go. Chemistry. Carbon tetrachloride.
I don't think so.
Yes, you do.
Go biology.
Keep going.
So if it doesn't say grams of something else, it's grams of that. Yeah, I'll actually do. I'm gonna write that more also.
Just had a good question on calcium nitrate one. Calcium nitrate's formula is parentheses 3, parentheses 2, right? So when you're adding this up, you are adding up a calcium plus how many nitrogens? 2 times imaginary 1. So that 2 applies in. Okay, that 2 is a multiplier. It's foiling or distributing. It's distributing. So 2 times 1, so that's plus 2 nitrogens. And then how many oxygens? 6 oxygens. So 1 calcium, because there's only 1 calcium there, plus 2 nitrogens, because there's a 2 and a 1, so that's 2 nitrogens total. And then 2 times 3 for oxygen gives us 6 oxygens. So that's what I'm telling you. When you're adding up your molar mass, the parentheses matter because they apply to the subscripts apply to everything on the inside of the parentheses. So then you guys can come out molar mass once you get there. Yeah. What's the number? No. I want to know the grams of calcium nitrate. What's the molar mass of calcium nitrate? That's what I got. Sorry. So that's what you're going to use in your conversion. But I'm not writing the answer up there just yet. You guys keep working. Question on number 4. There was a one-step process from moles to grams.
So, once you have the formula, how did you get to
The formula of calcium nitrate, I multiplied 5.08 times 164.08. So you guys on number 5, tell me what you're doing on number 5. You're multiplying by what? 22.4. Okay, because you're going to liters, right? So you're going straight from nitrogen gas, straight from moles to liters is one-step process, right? So that's why you get to use that 22.4 number. Don't use it willy-nilly now. It's only for gases. So 22.4 liters, 1 mole of gas, of nitrogen gas, and that is 19.6 liters of N2 gas. Raise your hand if you need me. Keep going. Huh? What? Yeah, I said we'll have to do it tomorrow, but I want to make sure people who are not going to be here tomorrow get their questions answered. I just had to adjust real fast. if you guys know what hydrogen peroxide is? What's the joke? Guy walks into a place and asks for water, so he got H2O2. Next guy said, I want H2O2 too. I want H2O2. Hydrogen peroxide. That's hydrogen peroxide. H2O2. Just FYI.
Funny.
Yeah. That's right. Looking at 6 through 8, so if I need to do another one, yeah.
But that's not because does that mean yellow?
I totally lulled. Totally. No, I have read all the experts. No, but one person literally, like, from our fourth grade, cracked me up. I'll tell you guys a joke another time. 6 through 8 is there one I need to do?
Attention all homecoming nominees, when the bell rings for till A time today,
6 through 8?
all nominees and their escorts should report to the football field. Again, all homecoming nominees and escorts, report to the football field for till A. Thank you.
Okay. Looking at 6 through 8 right now, tell me which one you want me to do, because I'm going to do one more right now. Yeah. 7. So 1 mole of H2O2, 0.160 moles of hydrogen peroxide. Okay, I can't go from moles of hydrogen peroxide straight to grams of oxygen. Anytime you see that you're transitioning from a compound to an element within that compound, that's when you have to use that internal mole ratio. So I'm in moles, which is great. I don't have to get to moles of hydrogen peroxide, I'm already there. But now I need to get out of moles of hydrogen peroxide to just simply moles of oxygen. So get me to moles of oxygen using your internal mole ratio trick. So for 1 mole of H2O2, how many O's are in it? 2. So that 2 means I have 2 moles of oxygen within it. And that's our trick one. So, and I will help you more with that if needed. But 1 mole of oxygen, just straight up O, now can be converted to grams of O. How? Right, the moles on bottom, so 1 mole of oxygen on bottom. And what's the grams of oxygen?
30.
It's not diatomic oxygen in this case. Good point. This is not diatomic oxygen because this is just simply an atom of O, an atom of elemental O. Molecular diatomic oxygen would be O2, but this is just 16, not 32. The 16 16 grams. So in your calculations, you would do moles of hydrogen peroxide cancel, moles of hydrogen peroxide cancel, moles of O cancel, moles of O cancel. So 0.16 times 2 times 16. Don't know. Oh, it's right here. 5.12. Okay, so the other 2 are for you guys. Before we leave, I want to make sure we all understand what Mythbusters kind of is. I did not explain that well yesterday because it was at the end of our test. Huh? The test, the multiple choice, I'll have to do it during tomorrow because I got 4 minutes and I need it back because I haven't recorded them yet. But I can let you see it during teal. Okay, so I will come back here if I need to. But under our Honors Chem page, under Documents, if you go scroll down to towards the bottom of Documents, make sure you're watching up here so you guys can make sure you know where to investigate later. It says Mythbusters Honors Project, right? So I've got some example lab reports up here because some people were like, I don't know how to do a lab report. But that's towards the very end. What you are working on first, a little bit towards the bottom, it says Mythbusters things with dates. That's not actually the most updated one because that was updated in January. Underneath our homework page, you saw there was a link for, I'll just go there now because you guys can ask me where it is. So at the very bottom, it says complete the honors project Mythbusters online with your partner, and here's the project due date. When you click that, you can do it. Computadora. There you go. It will show you exactly what you're looking for. So these are some limitations of the project. That what you're going to do is today, by tonight, find somebody to work with because it's too much for one person. You're going to come up with some exciting ideas that you want to test. It's usually like for example, somebody tested in the past does tapping on top of a soda can really limit the amount of spew that comes out? It was just something interesting to test about. It's all scientific. It's related to chemistry in some form. And it's kind of a myth. It's something that somebody put out there like, oh yeah, it's totally true, but you're testing if it's true. So with that in mind, come up with something that you're interested in because you're going to be working on this for a while. The first thing that's due is the idea. So the Google form online link by Friday. I will approve your idea. I'll pick 1 through 3. Prioritize it. The first idea is what you really, really want to do, and then second and third are just I'm like, yeah, I'm okay with. And then after that, you're going to make a research brief. And the research brief is just like you looking up some stuff about the chemistry behind it, about the idea to see if it's really a viable process. Is that going to be something that you can actually do an experiment on? And that's like a 1-page paper about the background of that idea. So you can start looking at that now to even see if it's a viable idea before the research brief is due. Because that right there, once we hit that part, if it's not a viable idea, if it's something that, yeah, I can't really test, don't really think I can do an experiment on, we're going back to Mythbusters' idea and choosing a different one. So you can kind of do the research brief. You're looking up stuff now and just save like the links so that you can actually write it up later. But as you can see after that, after you submit your research brief and I read over it to make sure it's good, I'll approve you to start making an experiment. That's basically you'll come up with a procedure. You'll get that approved by me. Then you'll actually do the procedure and you'll share results with me. And then you'll actually show everybody your results like in a video or a prezi or pictures, whatnot in January. So the due dates are like you'll conduct testing until December the 4th. I'm sorry, share results with me on December the 4th. You'll submit your lab report to me on December the 18th, and then you'll give us a quick 5-minute presentation or less. It's 5 minutes, that's it. And that one's in front of the class. So most of our presentations are like peer groups where you do little stuff with each other. It's a little less intimidating, but up in front of the class, I mean, I do it every day. It's not bad, okay? Just do what you got to do. And then you'll talk to us in January about it. So it seems like a long ways off, but I have this segmented out in dates for you because you will stress yourself out if you wait to do a lot of this until December. So that's why I want you to baby step it, okay? It's more for you. Make sure that you don't overwhelm yourself. But questions on Mythbusters right now? Do you guys have your partnerships? You just want to talk to people. Go talk to people right now, okay? Finish up those last 2 and start reading our yeah.
I have a question about what do you